Dr. Paul has covered some portion of this in the morning today. There was a time when digital twins, people used to think that they can be done only for the cost-intensive equipment sitting on the P&L sheet, actually. But the life has moved on. In last 2 decades, we have seen that moving on from assets to the complete processes and looking at it in end-to-end perspective. And in fact, closing the loop actually, can we pick up the innovation points from the throughout the life cycle of the development of the product? That's where digital twins are playing a big role today. You talk about the structured data, you talk about the unstructured data, bringing in the AI, ML aspect of it, in the prediction, actually, what will really happen. I'm not talking about the trivial use cases which we used to talk about earlier, the predictive maintenance, preventive maintenance. Yes, of course, we are doing that today, but we are far ahead in the game. That's why it is called Digital Twin 2.0. It is, we were discussing just before the session, it is prevalent not only in manufacturing today, it is there in all the verticals you talk about. I'll not specifically touch aero and auto as both the industry leaders are here, but if I talk about the other areas, see life sciences, we are having people who are being treated as digital twins, the patients. If you want to personalize the treatment, that is how the digital twins are being used. Get into a cave-shaped mine, actually, a kilometer down, and you will realize how people are connecting, how the ore is extracted, transported, conveyed, and everything, actually. It is, we have seen this transformation happening. Getting into little more details, Latha, I'll start with you first. How has digital twin adopted in the mobility industry, actually?
Yeah, it's an interesting question because I may have to tell there is no area in the mobility industry which is not affected by digital twin, right? So let's maybe start with the basics of supply chain management, where we get material from. So supply chain management in the automotive industry is pretty much complex. So if you have played this game called Jenga, it is like, you touch one portion and the entire tower fails. And supply chain is like that in the industry. It is kind of so many distributors, so many stakeholders, and it's a very intricate network that we need to navigate through. And if you look at the last 3-4 years, the supply chain, global supply chain crisis that we had, it has really hit all of us. So when you look from that perspective, the digital twin, if you create a digital twin for supply chain management, which kind of replicates the entire supply chain, there is a lot of benefit that we see. So one is the demand forecasting, which can be done effectively. It can talk about the inventory control, which can be done very, very effectively. Efficiency. But more than that, what we see, for example, we had the semiconductor crisis. So when we have crises like this, using a digital twin, it is easy for us to simulate certain conditions and also see where the impact is, what can be an alternate supplier, and so on. Similarly, when we have surplus demand of certain components, when the market changes, and there's a surge of demand for certain vehicles and certain components, I think it's pretty much easy to have the digital twin and navigate this kind of a challenge very easily. So that's starting from the supply chain. Then when you come to the manufacturing setup in the production plant, whether it is a process optimization or whether we're talking about quality control where digital twins are used, gaining efficiency, there are a lot of areas where we can use. But the interesting part is that you also need a lot of data for this to happen properly. So that's on the manufacturing. And when you come to R&D, from Texende India, we work a lot on the connected, automated vehicles, And in a complex system like ADAS, it is very clear that we are not able to do the entire test on a physical vehicle. And the time to market is a very important factor. And in these scenarios, wherever we have the virtualization in the starting from design to prototype to testing and validation, in the whole chain, digital twin is being used. And again, taking it one level further, if you use generative AI and synthetic data for the autonomous driving, this is another use case what we can use. So, so whether it is development, manufacturing, supply chain, and any other area, if you look at it, it can be there. And another big use case which is coming is also in terms of skilling and training. So you have this very, very expensive equipment, either in the plant or in other areas. And it is not really possible to have any malfunctioning, or maybe you cannot afford an error in these areas. So that's where digital twin, along with the Gen AI, voice, integrated with voice, it is very easy for us to actually use it for, upskilling and training of new personnel. So I would say that, the list is pretty long. And even the advent of software-defined vehicles and the new technologies coming in, where time to market is an issue. We had recently, just a couple of hours, we had a discussion on how do we compare time to market between India and China, and how do we really move up the value chain from India. And digital twin for us in the automotive industry is a real, true enabler to make this happen. Yeah.
Thank you for elaborating this so beautifully, because you talked about the breadth and you also covered software-defined vehicles. And I think our previous panel was also talking about software-defined X. So maybe I'll ask the same question. A similar question on that is, what is happening in the next-gen mobility space as people are talking about software-defined vehicles? Of course, we have seen the era of software-defined networks, software-defined X, and then now software-defined vehicles. How will digital twin expedite the deployment of this solution in market really?
So I would say digital twin is the only way to expedite the development of software-defined vehicle. And see, if you look at the entire concept of software-defined, I think the previous panel covered it, but just to emphasize on it, one is basically the time to market is a topic, right? The second thing is predictive maintenance is a topic. And then if you have certain over-the-air updates which are getting onto the vehicle in a very safety-critical industry like automotive, it is really not possible that we deploy it on the physical vehicle and then test it. So there is a lot of simulation which is possible before we deploy these solutions in an SDV context where we can use it. The second thing is, I was interestingly talking to, Satish maybe a couple of minutes back, and we were discussing on how digital twins are being used in other applications. So he was, talking about digital passports which are coming in for the truck drivers, and how digital twin can be an enabler there. And again, you look at certain OEMs where the over-the-air update is provided. For example, a set of premium customers are chosen, and their driving patterns are getting analyzed at the back end. And then you flash certain software, and you can actually get benefits from that kind of a context. So, and if you look at the EV space, we also have, the range anxiety is a big topic, and that is one of the, barriers of adoption of electric vehicles which is coming in. And in this case, digital twin is very useful, because whether it is state of health or state of charge of the battery, digital twins actually play a very important role, because the entire calculation can be done on the cloud and then replicated. So to overcome this range anxiety, this is some topic which we are using. Again, in the autonomous vehicle, the autonomous driving space also, along with the SDV, we use, digital twins, so that many of the scenarios can be actually simulated before the vehicle is on there. And for India, it's a game changer. I would say how it benefits India as an ecosystem. It mainly because earlier, a couple of years back, most of us, we were not able to achieve certain value growth because we had lack of infrastructure. And the reason quoted for not giving a Japanese project or maybe a European project to India was that you don't have the necessary test vehicles. So this concept of test vehicle is becoming redundant now, because a lot of prototyping, validation, and testing can be done in a virtual environment, and n number of scenarios, umpteen number of scenarios can be actually simulated before the vehicle goes onto the road. So I would say that there are, many use cases which are there in terms of the SDV, supporting time to market. We talk about in one day road to the cloud kind of a concept. So even Continental, we have tied up with, for example, Synopsys and Continental, we work together on a software-defined vehicle where we talk about, edge concept, and a cloud is coming from Amazon. So there are also a lot of collaboration which is happening in this space, which is making, digital twin comes from the Synopsys side, and the rest of the technology comes from Continental, cloud from Amazon. Whole lot of collaboration in this ecosystem, which is taking the whole digital twin concept and the SDV forward.
Thank you, Latha. And this is very interesting. What I could understand is that all the four C's, if you really see, the consumer, the car, the cloud, the collaboration is coming together actually when we define software-defined vehicles. And as you beautifully said, that possibly this era of testing the cars in a manual way will go away actually, possibly.
And
So,
also to add on would be even the design part, right? So there is a 100,000 possible combinations of designs which can be tested virtually, and also even deployed in a simulation environment. The aerodynamics and how the vehicle would really behave in a particular environment also can be simulated, which was not possible in the past. And that's actually a big game changer for the entire mobility industry.
no, thank you. Savya, moving you to next. I think your industry was the industry which picked up the digital twins in the start. Means if someone can really define digital twin 1.0 and 2.0, it is your industry. Starting from the pay as a R basis, from there to now, actually, what are the typical use cases which are being used in aerospace industry in different life cycles? What kind of ROI you guys have seen in last a decade possibly because you adopted it in the early days?
Yeah, no, thank you, Vikas. This is a very interesting topic for me, and it's interesting, Latha and I are from very allied industries. The only thing that separates the industries is the amount of regulation. We are a highly regulated space. As you can imagine, you don't want to be in a plane where the cockpit, the pilot goes, oops, my screen went black. That's not a good situation to be in. A lot of people have flown in, will probably agree with me. Aerospace as an industry, you think about, let's take, a plane, for instance. Highly complex system, safety critical system, everything multidisciplinary sort of fields involved in that. Be it in terms of a lot of hardware, electronics, heavily mechanical devices, electromechanical, and tons of software. The aerospace industry today is embarked on a digital engineering journey to not only bring about ROI in terms of what we do, but also make our systems more safe, more robust, more secure, and not to forget, more sustainable. Let me talk specifically about Collins Aerospace. We are embarking on this journey called Digital Product Lifecycle, DPLC, offshoot of digital engineering, where we are looking at digital engineering and digital twins in every aspect of our product development lifecycle. When you look at digital twins from a development life cycle, you can think about it in three phases, right? You can see as designed phase, you've got twins for as designed, then you have twins for as built, and you have twins for as maintained, right? And we have deployed twins in all these phases. Now let me give you a few examples, and these are from our office in India. So I don't want to give you other examples, but quote from what is actually happening on ground in India from the offices of Collins Aerospace. Let me give you an example of an as designed. So something maybe as simple as a digital twin for pressure release valve of an oxygen system. The oxygen that is getting pumped in into the planes. We have a digital twin with fault injection capability that we have built. And by bringing in this model, we were able to redesign the valve. And we were able to reduce the cost of the valve by 10x, 1/10 of the cost, by just making sure we have built a robust design exclusively using the twin, right? Now let me give you an example of an as-maintained sort of twin. This is an example of a brake control system that is deployed into the field. So building a twin for a brake control system with PHM capability, we were able to zero in on the root cause of some pressure oscillation that was happening in the system in the field, that I can tell you we would not have been able to figure out otherwise. It would have taken us a lot of time to figure out something like this, and the digital twin made it happen for us, and we were able to report the fault in a very quick succession. So these are a couple of examples. I want to tell you, we built a green factory in Bangalore, very close to the airport. And we used digital twins to not only visualize the layout of what the factory would look like, we were able to optimize it in a way that was enabling the flow, the capacity, as well as throughput of the factory. So these are some, I would say, use cases of what we have done right here in terms of bringing real benefits of, where we have leveraged real benefits of digital twins in the entire product lifecycle.
No, thank you, Savya. This is really interesting and glad to hear that you are able to close that loop actually. Reason being is we keep talking about digital threads, right? We keep talking about as design, as engineered, manufactured, serviced, but we do not close the loop in the last. And very happy to hear that guys are able to close the loop and are able to get those benefits by implementing digital twins. Looking at time window before NASCOM team start telling us, please, please go away from here, Bidisha. So what I was saying is, I definitely wanted to ask you one question, which is the buzzword of today, which is, any guesses? Yes, AI. So I want to ask both of you. I'll start with Sabya, you. Sabya, how will AI complement? While I appreciate and the team sitting here, industry leaders understand AI is already plugged into digital twin. But how do you see, what is your vision that AI will complement, okay, this digital twins in the future? How will this journey shape in coming decade or coming few years of AI or Gen AI getting embedded into digital twins further?
That's a great question because I think they go hand in hand, especially with now, better data acquisition and better processing capability, we are able to build more and more complex sort of models. The challenge is we are now starting to build, take up even bigger problems from a digital twin perspective. I mean, let me give you an example. In the future, we'll probably start building digital twins for something like an airport. You can imagine how complex something like that would be because there is the land side operation, there is the air side operation, all the operations within the airport, there are processes, there are people, innumerable number of systems that are all part of the airport ecosystem. And can you imagine a physics-based or a mathematics-based model to model something like that? It just becomes highly, highly complex, multiple inputs, multivariate, multiple outputs, coming out of a system like that. So you obviously need, something like a, deep learning, neural network algorithm to support, the digital twin capability for us to be able to still make accurate predictions, using digital twins. The other thing that we are doing is we are leveraging, generative AI to also come up with different design options. So not just one design, but multiple design options that can suit the requirement, and then we are able to take a decision based on all the other requirements or parameters that we have. Lastly, the predictive capability. Digital twins are feedback and feed forward sort of systems. Feedback is where we are getting in data from the field, but the feed forward is where you're predicting. And for accurate prediction, especially for highly complex systems, AI is going to be a great complement to the digital twin capability that we are envisioning.
Thank you, Savya. I have the same question for you, Latha. That how will AI complement digital twins in the mobility industry?
Yeah, I think since both these industries are pretty much having a lot of synergy, I think Savya answered a lot of it. But according to me, I always tell that AI and digital twin are a dancing duo. And the best partnership comes out when both of these things act together. And the real capability of digital twin is when AI can actually help to bring in more predictive capabilities into the entire system. The interesting part is that if you look at any of the digital twin systems, there is a huge amount of data that is there. And let us assume that you need to create a digital twin of a factory and then look at how do we improve the quality control or how do you improve the predictive maintenance part in a factory. So most of our factories, I mean, mostly the Indian ones, you have a lot of legacy systems, you have got a lot of maintenance manuals, you have a lot of operative videos and instructions and so on. So this data is too much. And if you, and for the digital twin to intelligently act on it, it is a little bit difficult. So I think that is where the LLMs play a very important role on looking at this data and compress it into a form where the actual content is not lost or the most important portion is not lost. So this is something, which we do in most of the factory because most of the areas, we start with basic things and huge data which doesn't make sense to a digital twin. So fine-tuning of this data and, using algorithms so that we can derive a meaningful output. That is how this duo work together. Yeah, and in a manufacturing setup, yes, it is really helpful. But even at the same time, even in the software-defined vehicle scenario or an autonomous vehicle, autonomous driving, actually what happens is you are putting the artificial intelligence behind the steering wheel instead of a human being. That's what is the ultimate, the L5 of autonomous driving. In all these scenarios, we see that a synergy of AI and digital twin come together. But at the same time, if you ask me in the auto industry, how much of Gen AI and digital twin is working together, I don't think that there are too many examples at this point of time, except that we are using voice-based systems for training and other purposes. But in terms of production, in terms of prototyping, I am not seeing too much of Gen AI at use at this point of time. But I'm sure as the technology evolves, as you told, it's a buzzword now. As when it evolves, I'm sure the scenario will change. Yeah.
Thank you. So I fully agree with both of you that AI and digital twins, we have to go together. There is no choice. Whether we like it or not, they will have to go together. In fact, I'll give you one good, interesting case study where in a different industry type, the Gen AI and digital twins are working together in the area of smart spaces. So today we are not only creating digital twins of only the equipments, right? The digital twins of buildings are also getting created. So where this MEP it is called, where the mechanical, electrical, plumbing has to happen, the Gen AI goes into it and based on the human behavior or of that topography, it tells you actually that switch has to be at this place, which is a very interesting concept. That's how Gen AI is helping you to reduce the waste, rework completely by getting in the digital twins of the buildings. So where you talked about data, and this question every time whenever we talk about this in industry comes in our mind actually. The structured data getting into the digital twins, unstructured data getting into the digital twins, the historical data getting into the digital twins. In future, do you see this, that the challenge of cyber security or the data security or the data privacy, will this restrict the usage of digital twins to only certain industries? Will the companies like FS, companies like healthcare, insurance, life sciences, will they be able to pick up digital twins in future as the other industries are?
Yeah, no, because this is it's $1 million question. Data and the challenges around it are still very real and are barriers to moving forward with it. Things like who has the data ownership? Think about the airline industry. Who owns the data? Is it the component manufacturer? Is it the OEM? Is it the airline? So it starts from then. Who owns the data is a challenge. Data privacy with different jurisdictions having different sort of regulations continues to be a challenge. The other thing I would say is, in the future, you think about a system of systems where you will have to bring digital twins together. So interoperability of the digital twins also becomes important. So the interface and the data, the standards of how you exchange data also start becoming more and more important. So I think as an industry and as governing bodies, there is a lot more work to be done in these areas. Hopefully, all industries will be able to leverage a powerful capability like AI, but digital twin and AI, but the problems today are real, and I think it's still something that needs to be overcome.
Thank you, Savya. Yes, this challenge, I think this thought process still has to evolve in the industry, the standardization on the cyber security aspect in the few fields, not in all. Savya, one more thing which I wanted to ask you was, you touched upon a very beautiful point and strengthened my thought process of digital twins, that assets to processes to ecosystem. And you talked about in that ecosystem, the airport system itself, where the complete supply chain, end-to-end visibility of the complete process. So in your view, will this adoption get evolved in other industries also? Will the digital twin 3.0 possibly, say 5 years, 10 years down the line, people will start talking about end-to-end more instead of talking about specifically in a point function solutions today?
Yeah, no, I think there are a couple of panelists who have already commented on this, which said, these tools are not for every problem that you have. Right now, I think AI and digital twins are like hammers looking for a nail. We are looking for what is the problem area so that you can go and put that. So it's not for everybody. For one, it's expensive to bring such capability on board. You need a lot of amount of data to be able to do something like that. But I do see us starting to work in terms of, bringing digital twins in more and more complex sort of ecosystems. Like you said, where there are people, where there is, a heavily processed sort of environment and, assets and products all sort of interacting with each other, definitely I see that happen. But my sense is as these things start becoming more and more complex, the ROI starts diminishing, right? I mean, you can make a digital twin of Bangalore. What will you get out of it? I mean, so I think it is what is the problem that you're trying to solve and what are you trying to get out of it will decide what kind of implementation sort of will work. Also keep in mind, a digital twin will last as long as you keep it current. If you don't keep updating it with data and keep it relevant, it will try to drift away, right? So these are some things that we need to keep in mind because it also has a life cycle. And unless you keep sort of investing in it, it'll tend to drift away. So not an answer to everything, but I do see its adoption going across industries and it becoming in terms of more and more complex applications.
No, thank you, Savya, on providing your thought on this. And this is super important, actually. The cost-benefit analysis, the diminishing ROIs. We can't just think about digital twin for everything, right? We'll have to figure out what kind of reliability, availability, maintenance, data you're looking at. What degree of accuracy, actually, from which system, correct? You can't model the complete system without looking at the cost-benefit analysis. Last question to you, Latha, looking at time. And nasscom team has beautifully placed 2 monitors in front of us, actually showing time. Last question is that what are the challenges which you see? Right? We keep talking about rosy picture of digital twins, but what are the challenges, entry barriers do you see for the creating digital twins? That is one. Do you see a different talent strategies which companies need to adopt really, looking at these challenges, please?
So I think if you talk about challenges, we can talk the next 30 minutes about it. But just in a nutshell, I think there are 2 challenges which you already brought out. The one is the data security and the privacy challenge, which we use. And the second one, what you brought out in terms of the ROI. Because when you present to the board that you need to have a digital twin concept, the first question that comes is how much of investment and when do you get the returns? And this is a very, very difficult question to answer sometimes because it's a moving target, because the data is evolving and we need to keep on updating the models. So, but the main thing is that it involves collection of huge data. So when you have industries where there is no IoT or AI or data or any cloud technologies which are implemented so far, to start from scratch, it involves a huge investment. Yeah, so that's number one. The second thing you touched upon is also the talent part. So what kind of talent do you need to build this kind of an ecosystem? So the typical talent that we have in our organizations is not enough because we should be having the capabilities of building the virtual model, which means that we need an upskilling, reskilling, deskilling of many of our resources into AI and data and cloud, which is really required. And on top of that, the challenge is also the mindset. Because when you walk into a typical shop floor or a manufacturing system, how open are the people to use the digital twin for maybe a predictive maintenance, or what is the trust on the system itself? Because we are talking about, in our manufacturing systems in India, a very different type of talent, a very different type of skill sets what we have. So this is, these are some of the things which I feel, looking at the monitor, yes. These are some of things which I see. But it is imperative that this technology is here to stay in tandem with AI, in tandem with data, in tandem with cloud technologies. I think there is no other way for us to move forward without this, yeah, in spite of the challenges.
Thank you, Savya. Thank you, Latha, for taking us through the complete spectrum of digital twins, the breadth and depth of it.
For more content on tech and leadership, subscribe to nasscom YouTube channel and press the bell icon to never miss an update.